Hi class, in lesson 2 you will be learning about the area of triangles and quadrilaterals. Please read over the learning goals for the lesson and make sure to look for the key terms parallelogram, altitude, variable, and trapezoid. Please turn to page 17, activity 2.1, investigating the area of a parallelogram. In this activity, you will investigate the area of a parallelogram using what you know about the area of a rectangle. A parallelogram is a four-sided figure with two pairs of parallel sides and opposite sides that are equal in length. Please answer number 1 and number 2 with your group. In a parallelogram, any of the four sides can be labeled as the base. The altitude of a parallelogram is another name for the height of a parallelogram. The altitude of a parallelogram is the perpendicular distance from the base of the parallelogram to the opposite side, represented by a line segment. Please answer number 3 with your group. For number 3, here is an example of how you can label the base and height of the parallelogram and rectangle. Please turn to page 18. Answer number 4, number 5, and number 6 with your group. Please remember, for number 4, when you write a sentence to explain your reasoning, be sure to express a complete idea. Your sentence should make sense standing alone. For number 4, the heights of both the parallelogram and the rectangle have the same measure. The bases of both the parallelogram and the rectangle also have the same measure. For number 5, the areas of the parallelogram and rectangle would be equal. And for number 6, to calculate the area of a parallelogram, you multiply the base times the height. In mathematics, one of the most powerful concepts is to use a letter to represent a quantity that varies or changes. The use of letters, called variables, helps you write expressions to understand and represent problem situations. Please answer number 7 with your group. For number 7, the formula to calculate the area of a parallelogram and a rectangle is A equals B times H. Please turn to page 19, activity 2.2, investigating the area of a triangle. The base of a triangle, like the base of a parallelogram, can be any of its sides. The height or altitude of a triangle is the length of a line segment drawn from a vertex of the triangle to the opposite side so that it forms a right angle with the opposite side. Sailboat race courses are often shaped like triangles. The course path is defined by buoys called marks. When the course is triangular, the marks are located at the corners or vertices of the triangle. Here is a sample course with the marks numbered. Race officials need to know the area inside the course so that they can plan for the number of spectator boats that can anchor within. Please turn to page 20. The triangle represents a sailboat race course. Each square on the grid represents 1/10 of a mile by 1/10 of a mile. Please answer number 1 with your group. For number 1, your estimate should be close to 0.63 or 63 hundredths square miles. Please answer number 2 and number 3 with your group. For number 2, here is an example of how you can draw a parallelogram on the grid. The area of the parallelogram is going to be 2 times the area of the triangle. And for number 3, the area enclosed by the triangular course is going to be 63 hundredths square miles. Please turn to page 21, answer number 4 with your group. For number 4, here is how you can label a base and height of the original triangle in the diagram. And to calculate the area of a triangle, you multiply 1/2 times the base times the height, or A is equal to 1/2 B times H. Please turn to page 22, activity 2.3, investigating the area of a trapezoid. You have seen that taking apart or decomposing a parallelogram forms a rectangle, and putting together or composing two triangles also forms a parallelogram. Composing and decomposing can help you think about the shapes differently in order to determine their areas. In this activity, you will take apart and put together shapes to determine the formula for calculating the area of a trapezoid. A trapezoid is a quadrilateral with two bases, often labeled B1 and B2. The bases are parallel to each other. The other two sides of a trapezoid are called the legs of the trapezoid. An altitude of a trapezoid is the length of a line segment drawn from one base to the other and perpendicular to both. Please answer number 1 with your group. For number 1, here is an example of how you can label the bases of each trapezoid. Please cut out 2 of the trapezoids at the end of the lesson to show how to determine each area for the problems on the following page. Please turn to page 23. Use the trapezoids that you cut out to answer numbers 2, 3, 4, and 5 with your group. After showing what Marcus, Zoe, and Angela did to determine the area, here is how you can calculate the area of any trapezoid in terms of the two bases and the height for number 5. The area of any trapezoid is half the product of its height times the quantity of the sum of the two bases. The formula would read A equals 1/2 times H times the quantity of B1 plus B2. This will conclude today's lesson on area of triangles, quadrilaterals, and trapezoids. Please let your teacher know if you have any questions. Thanks.